Okay, so didn't really give you time to work all this out, but I wanted to get a good start on it. To write this expression down, all you need is your R vector and make a vector out of this delta L increment, right? Well, delta L is just AI vector times delta L. That was easy. And the R vector is x star I plus aj, if we assume that this thing's in the xy plane. And where the y plane is arbitrary, and it's not going to make any difference, okay? Right? And the direction of this thing is, well, we'll just do the cross product and see, okay? So, magnitude of R is the square root of x star squared plus a squared. So, actually now, we've got everything we need to write the delta B, right? Okay, the I delta L is, and I'll write it as delta L times the I vector, cross with the R vector over R vector over its magnitude. So that's cross with, make a big cross to distinguish it from the X. And there we have the vector over its magnitude. And we divide that by the square of the magnitude of the R vector, which is, of course, x star squared plus a squared. And then what? Well, I cross I is 0. I cross j, well, I cross j is k. Okay. There's something about that disturbs me. So let's be sure, because my problem is, and I really don't see, so I've got this idea in my head that I've got to check out because something is bothering me here. Okay? Delta Li is always in this direction, right? And R on this side of the axis is in this direction, so when you cross it, you get this, right? I'm thinking when we're on the other side, the cross product, well, no, it still works, okay? Because now your R vector is here, but still you're crossing this with this, and you're still within 180 degrees, and you still get this, right? Okay? So, and it's, yeah, that was really kind of a little bit of an ignorant hesitation that I had, because, of course, if it was the way I was thinking, by reversing, by having the R vector in this direction, if that changed the sign of the cross product, then the cross product you get on this side would cancel the cross product you get on this side, right? So, clearly you get a field. We observed that in lab. Put a little wire over a compass or a compass over a wire and set a charge or a current through it, and you get a deflection perpendicular to the wire. Okay? And of course the K vector is now out of the board, looking for the word for this thing, out of the board, okay? So it's perpendicular to this, and it doesn't matter where the y-axis is, okay? So if you rotate the board a little bit this way, well, the current is still perpendicular to that, and it doesn't take too much imagination to see that what that gives you I said the current is perpendicular, the field is perpendicular to that magnetic field. It doesn't take too much imagination if you just think of rotating this thing through 360 degrees and seeing where the magnetic field vector goes, to see that the magnetic field at any distance surrounds the wire in a circular manner. Okay, we'll draw that. Okay, and make that a little more specific. Okay, well anyhow, that's a digression, but here we have this, right? And the cross product then is very simply, well, I'm just going to write it down. You can almost certainly see it. It's K prime times A delta L over X star squared plus A squared to the 3/2 power times the K vector. Don't just confuse the K vector with the constant K prime, 10 to the -7, so forth. Okay? Well, that's what we get for our delta B. But now, of course, that differs from one increment of length to another. And we're going to have to integrate that. So our variable of integration is going to be x. So this is going to approach the integral from -infinity to infinity of K prime A delta L over X squared plus A squared to the 3/2 times the K vector with respect to X. Now, a lot of this is constants. You know, the whole K prime A delta L and the K vector come out of the integral, and all you're integrating is then dx over X squared plus A squared to the 3/2. Very standard integral, easily done by trigonometric substitution. We're not going to work that out. Okay? You can look at the formula, you can work out the integral and see how they compare.